A ball is dropped from a height of 12.25 meters. The height of the ball, h meters, after t seconds can be modelled by the equation h of t equals negative 4.9 t squared plus 12.25. For part A, we're asked what is the height of the ball after 1 second. So the height of the ball after 1 second is h of 1, which is the same as negative 4.9 times 1 squared plus 12.25. On the CAS calculator, go into the main menu. Next, what we're going to do is type in the expression h of t. However, we're going to replace t with x, so we're going to type in minus 4.9x to the power of 2 plus 12.25. Now we're going to highlight that and go interactive, define as, and we're going to change the function name to h by clicking on the ABC and clicking h of x and defining it. And now that will just make our life a little bit easier. So for part A, we wanted the height after 1 meter, so we can drag down the h of x and replace x with 1. And we find that the height is 7.35 meters above the ground. So the CAS calculator gave that as being equal to 7.35, and the units is meters, so that is the height of the ball after 1 second. For part B, we want to find the derivative h dashed of t. Next on the calculator, we want to differentiate h of t, so we drag the h of x on our calculator down, highlight it and go interactive, calculation, diff, and then we want to differentiate h of x, so we press OK, and the derivative is minus 9.8x. So from the CAS calculator, we found that h dashed of t is equal to negative 9.8t. For part C, we want to find out how fast the ball is travelling 1.2 seconds after being dropped. So for this, we're going to use the derivative. So we're going to evaluate h dashed of 1.2. To evaluate the derivative, when x is equal to 1.2, we can drag the derivative down and we can use the keyboard and go to Math 3. And we can use this straight up and down line to specify that x is equal to 1.2. So that gives negative 11.76. So from the CAS calculator, we found that that is going to be equal to negative 11.76, and the units for that will be meters per second. However, the speed is just the positive quantity of the velocity, so the speed is going to be equal to 11.76 meters per second. The negative in the velocity simply says that the ball is travelling in the negative direction, which is towards the ground. For part D, we're asked after how many seconds does the ball hit the ground, and we want to state the answer correct to 2 decimal places. So the ground is going to be represented by the height being equal to 0, so we want to solve the equation h of t is equal to 0. Next on the CAS calculator, we're going to solve h of x equals 0, so we type that in and highlight it and go interactive, equation inequality, solve for x. And as decimals, we find x is equal to negative 1.58 or x is equal to 1.58, correct to 2 decimal places. Therefore, from the CAS calculator, we found that t is equal to negative 1.58 or t is equal to positive 1.58. However, t is greater than or equal to 0 because it's time, so it must be positive, which means that t is equal to 1.58 seconds. So that is how many seconds it takes for the ball to reach the ground. For part E, we're asked what is the average speed of the ball during the drop, and once again we want to state our answer correct to 2 decimal places. So we need to remember that the average speed is equal to the distance travelled divided by the time taken to travel that distance. So for this particular question, the distance travelled is going to be 12.25 meters because that's how high the ball is above the ground, divided by the time taken, which is 1.58 seconds. However, we will use an exact answer when performing this calculation on the calculator. So using the CAS calculator, the speed was equal to the distance travelled, which was 12.25, divided by the time taken to travel that distance. So I'm going to use an exact value and drag that down. So that's the distance travelled divided by the time taken, and hitting execute will give us the average speed, which is 7.747 or 7.75 correct to 2 decimal places. Therefore, the average speed correct to 2 decimal places is 7.75 meters per second for the journey of this ball to the ground.